Hi all, this is Deepak. Hope you all are doing well. Today in this video we are going to cover topic like how to build microservice with Spring Boot, Rest and PostgreSQL database. Although the screen is a self-explanatory enough to tell you what all points we are going to cover. So let me explain you all the points which we are going to cover in a sequence. First, we will create a database and table in PostgreSQL using pgadmin tool. Next, we will create a microservice with Spring Boot and configure PostgreSQL database properties in our application.properties file. Next, we will implement the CRUD operations with REST API and cover endpoints like get, post, update, and delete. Finally, we will test our REST APIs using Postman and verify the API response data in Postman as well as in database. So all these points we are going to cover in this video. So let us start with the first point, which is like creating a database and table in PostgreSQL. Let me open the pgadmin tool to create database and tables. So before we create database and tables, let me give you short introduction about the PostgreSQL database. PostgreSQL database is one of the world's most popular database, which is managed by open source community. It is an object oriented and fully ACID compliant and highly extensible. With the word highly extensible, it means that community can add features and capabilities on top of existing on need basis or demand basis. It runs on operating systems like Linux, Unix, and Windows operating system, and also supports and works with programming languages like PLSQL, C, C++, Java, Python, Perl, .NET, and there are lot many other languages as such. This is about the short introduction of PostgreSQL database. So let us create the database and tables. Herein we need to give password which we have set at the time of installation. So you can see here inside databases we have Postgres database, which is a by default created, and inside this we have options like casks, catalogs, event triggers, extensions, foreign data wrappers, languages, publications, and schemas. Inside schemas we have public folder, and inside that we have various options available like aggregates, collations, domains, and FTS related options, foreign tables, functions, materialized views, operators, procedures, sequence, tables, trigger functions, type, and views. So we can right click on tables, and there is an option like create table. With this we can create any table we want, but right now we are not going to create a table inside default database. Rather we are going to create a new database by using the option like create database. Herein we can name our database. Let's say it's order db. We can save it, and we can see the order db database is created with all the default options which is there for default database. We can click on schemas inside public folder. We can see there is a tables tab, and we can choose the option create table, and here we can name our table. Let's say order details, so it is like order details, and here we can add the respective columns. Let's say order id. Here we can define data type as an big int. We can make it as a primary key. Next we can add product id column, and here we can make it as an integer, and we can set not null as a true. Next we can add user id. Here again we can use integer, and we can set it as a not null. And next we can use order description. Here we can set data type as a character varying. We can set length as in 255, and finally we will add order status, with which we can set status like whether it is initiated, completed, or in progress kind of status we can set. For this we can set data type as a character varying. Character varying is nothing but the varchar data type, so we can make it as a not null. So we have created 5 different columns for order table, order details table, and these are the 5 different data types. Likewise we can create as many columns as we want. We can simply click on save. So what we have done, like we have created a new database with name order_db. Inside that schemas and public folder, we have created new table under tables, and our table name is order_dtls. Inside that we have created all these 5 columns like order id, product id, user id, order description, and order status. Fine. Now the table is empty for now. So want you can run the select script to verify if it is empty or not. We can execute the script and see there is no data present. So we have done with our first point, like we have created database and table in PostgreSQL database. Next point, we will create a microservice with Spring Boot and configure the database attributes in properties file. So let me open the STS first. Herein we need to give the workspace and click on launch. With this, like it will open with various options on right pane. We can create Java Spring Boot project with these options. We can select the third option, which is like create new Spring Starter project. Here we can give the name, like it is related to order. We can give name as order service. Select the build type as a Maven, packaging as a Java version as a 17, and here we can mention group as a com.order. And here artifact we can mention order-service, and here we can give description as an order microservice with Spring Boot, and here we can define package as in com.order. You can verify it once and click on next. Herein we need to add the dependency. What all dependency we need to add? First we will add Spring Web. Next we can add Spring Data JPA. Next we can add PostgreSQL driver, and finally we can add Lombac. So we have added all the 4 dependencies which is needed for us. We can simply click on finish. With this, it will create the project folder along with the default folders and files. Let us open the pom.xml file to check what all dependencies we have included. You can see here we have added Spring Boot Starter Data JPA. With this dependency, we can add entity and repository and make use of annotations for entity and repository, and create the component. Here is like Spring Boot Starter Web. With this, like we can use some annotations related to the controller, like REST controller @service stereotypes, and while creating the REST APIs, we can make use of get mapping, post mapping, and various HTTP method mappings like request body, response body, response entity, and there are path variables and other. We can make use of using this starter web. Next, like here we have added the Postgre related driver with which we can connect with the PostgreSQL database, and here is the Lombac dependency with which we can remove the boilerplate code and make use of the annotations provided by the Lombac, and we can mostly use it for the getter setters. Fine. So this is about the dependency which we have added. Now let us build our project using run as maven install. So we can see here is a build failure due to the test fail. So for now we can simply comment out the test and save it and rebuild it again. Okay, now we can see the build is success. Now we can start adding our configuration part in properties file. First we can change the port number. By default we are using 8080. Now we can use 8087. Here we can add the spring.data source related properties. We can add URL first. For URL we can add jdbc colon postgresql colon localhost 5432 colon. Here in this port number which we have defined while creating installing the database, this is the same port we are using. In case you are using the any other port, you need to mention that port 8 here, and herein we need to add our database which we have just created. Next thing, we need to add spring.datasource.username, and our username we need to give it. Similarly, we can add password for this username, and it is here. Now next thing, like we can add a spring.jpa.showSQL. With we can make it as a true, and with this we can view what string is getting prepared or executed string in console. Next thing, like we can add spring.jpa.properties dot hibernate.dialect, and we can pass org.hibernate.dialect. Now herein we need to specify our database related dialect, which is a PostgreSQL dialect in our case. Next, like we can add spring.jpa.hibernate and ddl auto as an update. That's it. I think we are done with our database configuration part. We can save it. We can check it. Yes, build is success. So with this we are done with our second point, which is like creating a microservice with Spring Boot and configuring the database inside application.properties. So next point, we will implement the CRUD operations with REST API. So first we need to add the required packages. So first we will create entity package. Next we will create a repository package. We'll create service, and finally we will create controller. So with this we have created all the required packages. Now let us add the required component or classes inside the entity or inside these packages. First we can add order entity. Here we can add required annotations like entity no OR constructors, all OR constructors, the builder, and the table. Herein we need to pass the actual table name which we have created on database side, which is like in our case it's an order DTLS. We can check it once. This is order underscore DTLS. We can add the imports, and so here like we need to add properties. First we can add private long order ID. Next we can add private integer product ID. Next we can add user ID. Next we can add order description, and finally we can add order status. With this we have added all the required fields properties. Now we need to add the ID annotation for our primary key for our order ID, and here we need to add generated value. Need to provide the strategy, which is like generation type dot auto, and we need to add imports for ID. So with this we are done with our entity part, which is like we have created order entity with all the required fields, and we have added ID annotations and all other required annotations as such. Now next thing, like we will create a repository. For repository we need to create an interface, and we can give name it like order repository. Here and we can annotate it using repository annotation. Here we can add extends CRUD repository. Here and we can add our order entity, and this is the data type of the ID, which is a long. We can add all the required input, can save it. With this, like we are done with our repository component. Next thing, like we can create our service component. First we will create our order service interface. Inside this we can add all the required methods. Let's say first we will add get all orders, which will return all the list of orders. We need to add import. Next we can add method for returning individual order object based on what ID order ID is passed. So here we can use input order ID. So here this is the input order ID, and for this order ID it will return the order object from the database. Next we can add method for add order, and here we can add actual input object, which is an order. So for this order will get saved into database, and finally it will return the saved order object. Here in like we can add update method. Here we can pass input order object, as well as we need to pass the order ID against which this order object will get updated and saved into database, and finally returns the updated object from database, which is return type is order itself. Finally we can add delete method, delete order, and here we can pass order input. So for update order method we do not need to pass the order ID, because we can pass this order ID at controller level and get the object and update it, and we can pass the updated input object at here, so that we can simply save it. Okay. Next we can create order service implementer class with name order service IMPL. We can annotate with service annotation, and this will implements order service interface. Can add service annotation, and herein we need to add all the unimplemented methods. Yes, we have added this. Now we need to provide implementations for all these one by one. Let us first inject service component, which is order service in our case. We can use auto-wire to inject it. Now we can make use of this. Okay, sorry, here we need to pass the order repository. We need to inject order repository, not service, because the service component we are going to inject in controller, and in service we are going to inject the repository. Okay, fine. Now we can call respective methods on this repository in our methods. Like for get all objects we can call find all, and this find all method is returning as an iterator of object, so we need to cast it to the list of order because this is our return type. Next we can call our find by id method, wherein we can pass this order id, and this find by id is returning as a data type which is optional order. So here we need to return only optional or only order, not optional, so we can call the get method on this. Okay, so here in you can see here for this given order id we may get order object or not in the database. If we do not get order object existed in database, in that case we need to handle the exception in a proper way, or catch the exception or throw the exception. The exception part we are not going to cover it here, so we are going to only cover the healthy path scenarios. Like for this order id we will get the actual order object. Those scenarios we will cover. For the next method, like we will add the order object. So let's say here we can call a save method, and what is the input order, we can save it. Next thing, like for update order, again we can call the same method like save, because we have here in like for input we are getting the updated modified order object, we are going to save it simply. And herein we can call the delete method, delete order, and this delete order returns the void data type, so we need to prepare some message which will be returning string like order is deleted successfully for order id, and we can add order dot get order id. So the order object is deleted successfully for the given order id. This message will get returned from the service method. Okay, so with this we are done with our service component, service level component. Now finally we will add our order controller. We can annotate it using rest controller, and inside this we can add, first we need to inject our service. Now we can add our gate mapping APIs, and here we can add our endpoints like, let's say, slash orders. For getting all the orders, we can add method like public list of order, and here we can call mention a method, define a method like get all orders. Now herein we can call our order service dot get all orders, and this will return the list of order. We need to add import for order as well as for list, and we are done with our first API, which is returning all orders with this endpoint. Now here in it is the return type is a list of orders. In case we want to state the add the status code or set some headers, then we cannot do this with this return type. Rather, it is always better to add a response entity or some response entity as an return type. The advantage of using a response entity, like we can set the response code as well as status code as well as the headers and actual object which is going to be returned. So all these things we can add inside this response entity. So we are done with our first API. So we can add next API, which is like returning the particular object on basis of what order ID is passed. So we can modify this method name and like mention it get order, and herein we need to pass the actual our order ID. Here we need to mention order ID, and here we will define our actual variable as an order ID input parameter. Now here we need to pass order ID, because on this based on this order ID which we are passing, the object will get returned. Okay, so we need to call the method which is available as a get order, and we need to pass the order ID inside this, so that it will return the actual order object and which will be set into the response entity. Fine. So we are done with our next second endpoint, which is like returning the individual order object on basis of what ID we are passing. Next thing, like we can use postmarking for adding order, and here we can change method name as an add order. Herein we don't need to pass path variable, rather request body is needed, and here we can mention the input order object which need to be saved, and here this object we need to pass, and here we can call the respective method for adding the order, which is add order. Fine. And here we don't need to pass the ID, because we are passing the actual object to be added into the database. So with this, like we are done with our add order API. Next we can add the patch method for the update order API, and herein again we need to pass the order ID against which we want to update the order. So we need to pass the actual object which is modified. Along with that, we need to pass the path variable or the order ID against which this object we need to modify. So here in like first we need to retrieve the object for the respective order ID. Let's say we can call the method, this method we can call to get the actual object from the service. So with this, like, we will get the updated order. Now we can check, like, if our updated order is not equal to null, then we can set values to the updated order. Okay, so here we can set values, like first we can set product ID and set value from our get value from our input object. Similarly, we can set the next value, which is like update user ID, and we can get user ID. So next we can set order description, and we can get order description from our input object. Next we can set order status, and we can get our order status from the input object. So with this, like, we are set our object, we have set all the attributes from our input object to our the object which we have retrieved from the database. Finally, we will call the update order method on service and pass this updated order to be updated into the database. What we have done, so we have two input params, like one is the input order and next is the order ID. So for the given order ID, we have retrieved the object from the database, and this object we have set new values from the input order, and finally on the modified object we are passing to be updated into the database. Okay, with this, like, we are done with our update API. So finally we will call our delete method. So for delete method we need to use delete mapping, and we can change this method as an delete order. Here we are the return type of delete method is a string. We can cross check it once. Yes, it is returning string. Now herein we don't need the request body, and the path variable is enough to delete the object. So first we will get the actual, so we will get the existing order object from the database for the given ID, and we can check if order object is not equal to null, then we can call order service dot delete order. Even, like, we can mention some string, and here you can say response message is equal to null, and we can set the response message at here, and finally we will return response entity. Here we can call, no, not delete method, we have already called it here. What we can do, like, we can set this response message at here, and the response entity will get returned. We need to add import for delete mapping. With this we are done. Okay, so with this, like, we are done with our all the REST APIs. or we are done with our CRUD implementations. So with this we are done with our second last point, which is like implement CRUD operations with REST API, and we have covered all the endpoints it here. Now next thing, like we will test it using REST API using Postman and verify the response data in Postman as well as in database. Okay, fine. So first let us check whether the application is in running state. Before we open the Postman, we need to build our application. We can run our application using Spring Boot. Okay, fine. So our application has started on port 8087. Now let us hit our APIs. Let us say here we can change the port number 8087, and our endpoint is orders. We can cross check here. This is the orders endpoint for getting all orders, and we can simply hit it to check. So right now it is giving the empty array because there are no records in a database. We can check it here. Basically it has created this columns as a duplicate one, so we can delete these duplicate columns. Okay, so we have the existing columns here, like order detail sequence we don't need, we can delete it because we are using the auto. So this is our order, and these are the properties which includes the camel case capital letters, whereas in our database we are using all the small case letters. So in order to map this, we need to add few more attributes in application.properties file. Let's say spring.gpa.hibernate dot naming dot implicit mapping. We can add Hibernate implicit mapping, which is like implicit naming strategy legacy JP IMPL. Next thing, like we can add one more property like string.jp.hibernate physical strategy. Here we can add physical naming strategy standard IMPL. We can save it, and here we can stop the application. We need to build it again. So these two attributes help us in case our column names and our property names are different. Okay, so our application has started successfully. Now let us check. Okay, so now what we can do, we can go and hit our first API, get all orders. Now it is returning an array, empty array, because we do not have added any, there is no record in our database as of now. We can check by executing the select statement. So we do not have any data as of now. So this response is correct because we do not have any data as such. Here we can add orders for posts. We will add one order. Let's say we can copy one order and we can add for our post method. product ID, user ID, order description, and order status bar. We can add product ID as a 1, user ID as a 1, order status as a order description as a order 1, and status is a initiated. So now we can click on send. So we can see the order is created with order ID 1 successfully. We can cross check it by calling the get method. Yes, you can see it is reflecting, and again in database we can check by we have this select script, we can execute it. Yes, we can see the order is added successfully. Now we will add one more order. Now let's say order product ID 2, order ID 2, and we can mention order status as order 2, and we can send it. Now the second object is added to database successfully with order 2. We can call the get method again. Now we can see there are two objects. Okay, so you can see there are two objects in a database. We can cross check it once. Now it is 1. If we execute the query, we can see there are two objects. Yes, fine. Now next thing, like we can update our, so we can get our particular ID. When we pass ID, so it should return the single object for that ID, so which is giving the response as expected. Next thing, like we will call our patch method for updation. For updation, like we can copy one input, one entry, and herein we can use the patch method, and for patch method we need to add the ID as well. So what we can do here, for URL we need to append the ID, and the order ID is the 2 which we are going to modify against, and this is the order object which we are going to modify. So we can mention the user ID and we can append double 2, and here instead of initiated we can say in progress, and we can send it. We can see the order is successfully executed and updated the record in database. We can cross check it by calling our get method as well as in database. We can see the status should be initiated, should show us once we call it. Yes, so status is in progress, which is like this, in progress. So and double 2 we have appended in our patch method. So the same record we can see in the table. With this we are done with our patch method. Next we can call our delete method and verify if it is working as expected. What we can do, we can delete the second object from the database and check if it is working. For delete method we don't need to pass the object itself, rather the order ID is enough. And we can see the order is deleted successfully for order ID 2. Now if we go and check with the get method, it should show only one entry. Yes, and we can cross verify in our database as well, and we can see the order ID second is deleted successfully. So this is about the our with this, like we have implemented all the points which we have discussed at the starting of this video. So as a recap, I will tell you what all things we have covered in this video. So first we have created database and tables using pgadmin in PostgreSQL. Next we have created Spring Boot microservice and configured PostgreSQL related database configurations in our application.properties file. Next we have implemented CRUD operations with REST API, and finally we have tested all the REST APIs using Postman and verified data in Postman as well as in database. So that's it. Thank you so much for watching this video. I would request you to please like and subscribe this video. Thank you so much for watching this video.